Newton's second law. Newton's second law helps us to derive the equation of force, that is F is equal to m into A. We should remember that Newton's first law defined force. It gave us the definition of force and consequently it also gave us the definition of inertia. While the second law gives us the equation of force, that is F is equal to m into A. The statement of Newton's second law says that the rate of change of linear momentum is directly proportional to the applied force and takes the direction in which the force acts. Again, it says that if there is a change in linear momentum, for example, suppose the initial momentum of a body is P1, that is equal to m into u. Its final momentum is equal to P2, that is m into v. Then change in momentum will be equal to P2 minus P1, that is equal to mv minus m into u. That is again equal to, if we take out mass to be common, then it will be v minus u. So change in momentum is this much. Now we are supposed to find out rate of change of momentum. In physics, when we use the word rate of change of something, that means we are dividing that quantity by time. So rate of change of momentum will be equal to same equation m v minus u, but that is divided by time. And this rate of change of momentum, according to Newton's second law, is proportional to the applied force and it takes the direction in which the force acts. If we do the derivation of this law, we finally come to the equation that force is equal to m into A. Thus, mathematically, force is the product of mass and acceleration. That is what Newton's second law is about. Next, we talk about units of force. We should remember that the equation for force is F into ma. F is equal to ma. Or if we replace A by gravitational acceleration, F will be equal to m into g. Instead of A, we are using g, that is acceleration due to gravity. Because of this difference in the acceleration, there are two kinds of units of force. The units on the left hand side are absolute units. The units on the right hand side are gravitational units. Absolute units. Absolute units of force are Newton and dyne. Newton is in SI system while dyne is in CGS system. There is a small relationship that we have to obtain between Newton and dyne. So we start with the equation F is equal to m into A. For force, I put 1 Newton. For mass, I put 1 kilogram. For acceleration, I put 1 meter per second square. We convert kilogram into gram, that is 1000 gram. We convert 1 meter per second square into centimeter per second square, that is 100 times. All the zeros combined together to give 10 raised to 5 gram centimeter per second square, that is equal to 10 raised to 5 dynes. So we are supposed to remember the relationship 1 Newton is equal to 10 raised to 5 dynes. Coming to the gravitational units. There are two gravitational units of force. In SI system, it is kgf, that is kilogram force. In CGS system, it is gf, that is gram force. We need to remember the convergence, interconvergence between both the systems, both the kinds of units. So 1 gram force is equal to 980 dynes and 1 kilogram force is equal to 9.8 Newton. This was all about units of force. Again, force has two kinds of units. There are absolute units and gravitational units. Absolute units are Newton and dyne. Gravitational units are kgf and gf, that is kilogram force and gram force. Also remember all the relationships that are given here. 1 Newton is equal to 10 raised to 5 dyne. 1 gram force is 980 dyne. 1 kilogram force is 9.8 Newton. The direct application of Newton's second law is the explanation of something that is known as an impulse. We define impulse as a force which acts on a body for a small duration of time but produces a significant change in momentum. Remember, impulse in simple language means a jerk, a sudden force that is applied on an object for a very small duration of time, but it causes a huge damage in the object or causes a great change in its momentum. That force is known as impulse. The equation for impulse is equal to force into time, that is m into v minus u upon t. Now remember, when time decreases, the force increases. That is, if the time duration for the application of force is less, then the force acting on the object increases. That is what happens in impulse. For example, let us take the example of a cricket player who is taking a catch. Now, when he is taking a catch, he swings his hands backwards usually. Suppose, imagine he is not swinging his hands backwards. If he is not swinging the hands backwards, the time for the impact of the force of the ball is very, very less. And hence, the force of the ball acting on his hand is huge, due to which he can get hurt. Conversely, if time increases, then the force acting on the object will decrease. So coming to the same example of the cricket player, when he is taking the catch, he is swinging the hands backwards. When he is swinging the hands backwards, he is actually giving himself some time to absorb that impact of the ball, to absorb the force of the ball. So when he swings his hands backwards, the time interval increases and the effect of force on his hands decreases, and hence he does not get hurt. So again, impulse is given by the equation impulse is equal to F into T, force into time, which is also equal to M into change in velocity. SI unit of impulse is Newton second. The CGS unit is dyne second, which are very similar to the units of linear momentum. We have one more example to explain the application of second law, that is impulse. One gets seriously hurt while jumping on a hard floor, but does not get hurt while jumping on sand or foam. This is a very common observation. If we are jumping on a hard floor, a cemented floor, we get hurt. Suddenly the bone is hurt. Our blood vessels might get injured, and then the doctor tells us to rub ice on that portion. That is because of impulse, a hard hitting jerk on our bone. Because when we are jumping on the hard floor, the time interval is very, very less, and hence the impact of the force is very large. But if we are jumping on sand, a heap of sand, or on foam, we do not get that much hurt because the sand yields, even the foam yields, it compresses. It gives our body some extra time to absorb that jerk of the force, and hence we do not get hurt. So remember here, if one quantity increases, the other quantity will decrease. If time interval increases, force will decrease. If time interval decreases, the impact of force will increase. That is direct application of Newton's second law, impulse. Newton's third law, the easiest law to understand. the easiest law to remember as well. Newton's third law says, to every action, there is an equal and opposite reaction. So it essentially talks about forces which occur in pairs. There is an action force and there is a reaction force. But remember, both of them are equal in magnitude, just opposite in direction. So if one force is 5 Newton, the other force is also 5 Newton. The only thing is, if one is in the forward direction, the other will be in the backward direction. For example, when we swim, we push the water backwards. That is the action force. And the water pushes us forward with an equal reaction force. Remember, action and reaction. Both of them are equal but opposite. When we walk, we push the ground backwards with our foot. That is our action force. And the ground pushes us forward. That is the reaction force. When the birds fly in the air, they flap their wings downwards. That is the action force. And the wind pushes them upwards. That is its reaction force. So remember, whenever one force is applied, immediately there is a reaction force coming into action. And that reaction force is equal and opposite. We have a slightly different question now. Why is it difficult to walk on a wet floor or sand or on marshy ground? Remember, when the floor is wet, that is, maybe it might be soapy or it is just watery, it becomes very difficult. There is a possibility that we might slip, or it is difficult to walk on a sandy beach or on marshy ground. That is because when we are walking on these kind of surfaces, we are applying some amount of force, but the ground is not reacting back enough. It is not giving us back that reaction force equally, since it is yielding, and hence it becomes difficult for us to walk. Hence, Newton's third law again says that to every action there is an equal and opposite reaction, but if there is not an equal reaction, it becomes difficult to do that work. That is all about Newton's second law and Newton's third law.